I'm Sam Shaner, Assistant Editor of QST, and today we're going to see how various ARRL staff can build their very own common mode chokes. These are relatively easy to build and often one of the first things a ham needs when building a station for HF. We've gathered people with different levels of experience to see how their backgrounds impact this project. We're going to be using common household tools that every ham should have, with the only difference being the fact that we're using ARRL Lab equipment to put it all to the test. Let's meet our competitors. First up, a new ham.
My name is Mimi. My call sign is KC1TJW. I've been a ham for about 3 to 4 months now.
My name is Mackenzie Ozick. I have been at ARRL for 3 months. I'm the book editor. I'm not a ham, and I don't have a call sign, but I am studying for my tech license, and this will be my first ham radio project.
Mackenzie's getting hands-on for the first time. Mark Dirks does a lot of portable operating.
My call sign is KC1RVQ. I've been a ham for a couple of years now, and I'm a general class license holder.
So we've got a learner, a tech, a general, and to make it more interesting, a veteran extra class operator in the competition.
My name is Joe Karsha. My call sign is NJ1Q. I am the station manager, W1 and W station manager here at ARRL, and I've been an amateur radio operator since 1979.
With such a pro in the mix, the newbies are feeling nervous.
We're building chokes. I've never built one before, so I'm a little nervous about it. It seems very technical, and I'm not a very technical person. A lot of my experience is with phone, so I am very nervous about doing something that is more on the mechanical side of ham radio.
I am not mechanically inclined, so I'll take my time, I'll be patient, and I'll see what happens.
How do you think it's going to go?
I think it's going to go okay.
Awesome.
And while this is a competition, it's still ham radio, and the amateur spirit prevails. Joe takes the time to help explain chokes in a way everyone understands.
Chokes are any device which are used to choke RF currents. That is a very simplistic explanation, but they are used to choke RF currents that may be traveling on the outside of a wire or coax.
Why do I need a choke?
Because on occasion, if you're operating a ham radio and you're transmitting and so on, and you find you have a high SWR condition, it may be because on your coax, on your transmission line, you have currents that are traveling on the outside. And these currents are actually causing a change in impedance, it's causing a high SWR condition. And by wrapping, not necessarily this type here, by wrapping your coax around a core, a ferrite core of some form, you will actually squelch or choke those currents that are traveling on the outside, because those are unwanted currents on the outside of the coax.
With a primer on what chokes do, the builders get to work. Joe is tackling the toroid core choke, but not before helping Mimi in the workshop as she prepares the PVC cord choke.
Again, the only thing we have to be careful of is where this is coming out and going in. So that's why we're using a bit slightly larger than the coax, because the holes are just to hold it in place.
Okay, let's see if I can do this correctly.
You can do it.
Oh.
Straight down.
Mackenzie has admittedly the easiest one to build. All she has to do is snap on the beads for the ferrite bead choke.
A lot simpler than I expected, but I had a lot of help and a lot of good information beforehand, so I felt like that really helped me prepare.
Across the lab, General Class Ham Mark is working on his ferrite binocular-shaped choke. He's got it almost finished when lab engineer John McAuliffe notices that Mark has it all wrong.
How's it going?
I'm doing good.
All right, I'm going to recommend that you may want to use more than one of these binocular pieces to make a choke.
All right. I thought that I was gonna take them and put them in series and
No, it works. It's going to work better if you make one choke using all of them in one loop.
Okay.
Because you're filtering in the loop.
Originally, I thought I was gonna take the binoculars and do them sort of in series, and I learned that that was not what we were going to be doing. Instead, I needed to keep them together, which made the coils a little bit bigger. That was interesting, and I didn't understand how important it is to sort of keep everything symmetrical.
Mimi has a similar issue with keeping symmetry as she winds nylon cord as spacers into her PVC wound choke. So what are you doing with the nylon rope here?
So I'm creating a spacer for the cord so that, hypothetically, it will create a smoother effect on the airwaves.
All right, great. Well, good luck.
Thanks.
As the build's near completion, the test rig is ready to evaluate whose choke performs the best.
We're going to be measuring the chokes that are built in the lab using this device called Nano VNA. This is a V4 version of that device. And we also have this very, very nice convenient test jig built by Halibut Electronics and put together by our good friend Steve Anderson to conduct the testing of the different chokes that will be built. And we're reading the device using a software called Nano VNA Saver.
John is going to use the Nano VNA, or Vector Network Analyzer, to determine what's called the S21 magnitude response of each individual choke. That's a measure of the ratio of the input power to the output power of the choke.
We're seeing exactly how much of the frequencies are being filtered as we sweep between 3 and 30 megahertz.
To add another variable, the YLs build a simple air core choke. It's a type you can rig up on the fly without anything other than a way to bind it. But as the time comes to see what the Nano VNA says, nerves are on the edge, or at least as on edge as they can be in the middle of a fun build project.
All right.
I feel the results will be fairly on target. We are talking HF here, so it's not as if we are looking for specifics with specific lengths or anything like that.
I hope it works. It was a lot more complicated than I thought it would be in terms of trying to make everything as symmetrical as possible, but I do think I did a pretty good job, especially since this is my first time building a choke.
So now that we've all built our chokes, who would like to have theirs measured first?
Should we start with the air core?
Let's go ahead with you, Mark.
Yes. All right. All right.
Thank you. So to test this, we're going to hook up the positive and negative ends of the dielectric. And we can see that we get a lot of attenuation around 11 megahertz, some more attenuation close to the 10 meter, which is roughly what we're going to expect using 8 turns with RG58.
So for the uninitiated here, what does the attenuation mean? What is that doing for folks?
So the attenuation is how much of the frequency the choke is filtering out at the given frequency. So in this case, we've swept between 1 megahertz and 30 megahertz, which covers some of the MF band and all of the HF band.
All right, Mimi, you're up next.
Okay.
We expect the air core choke to perform worst. So new ham Mimi didn't seem that anxious to have hers evaluated next. Surely it would be better than the experiment's control.
It was still connected, and that's why I
Didn't take.
It was looking up until disaster nearly destroyed the test rig.
Almost broke it.
Thanks for that catch. That was a good save. All right.
With crisis averted, it's time for the results.
So Mimi, we see with your choke that we do get a lot of attenuation up until about 22 megahertz, and then the signal increases quite a lot, and it stays about the same going into the end of the HF band. So generally we see more with this type of choke, and it's also more wide band, but it is not as it's not as complete as it could be. But very good job.
Thank you.
Mimi's choke performed well, but there's still 3 more to measure, including the ones built by much more experienced hams.
I'm nervous.
Why are you nervous?
Guess what if I didn't do it right? This is my first project.
All right, Mackenzie, so we see with your choke when we do our sweep that there isn't much attenuation at all on most of the frequencies. But this is to be expected. Now, when you're building one of these ferrite bead chokes, you want to make sure that all of your ferrite beads are really close together so you get maximum attenuation. When they're really far apart like this, the magnetic fields don't overlap and you don't get that really, really strong attenuation you might get with this type of choke. So we're going to move these down a little bit. So they're all in one spot, and do our sweep again, and we'll see better performance, hopefully. And now that they're all in one place, we're seeing slightly better performance. It's not making a very, very large difference because this is a very, very short piece of coax, but we are seeing that there is some more attenuation, especially at the 30 megahertz mark and at the 1 megahertz mark. So good job, Mackenzie.
Thank you.
All right, who's next? How you doing, Mark?
Good.
All right, let's take a look at this. So I gotta have this one. So Mark, what we're seeing with this coax choke is that there isn't, there's some pretty decent attenuation at about 1 megahertz, but it increases and it goes to about negative 10 dB at the end of the 30 meter spectrum. So you get some generalized attenuation, but you don't get much, especially once you get past 3 megahertz.
Okay.
So this would be more ideal for an MF band transceiver, but if you're not, but on HF, this is not very well performing.
Not particularly efficient. All right.
Not particularly efficient.
Cool. Thank you.
All right. Now we have our last contestant, Mr. Joe Karsha.
Joe has more experience than everyone else combined. Will it make a difference?
Very nice. So with this choke, we're seeing better attenuation than we were with the ferrite binocular choke that we had ran earlier. But we are seeing not so much attenuation once we get past the 20 meter mark, and it goes to about negative 12 dB at 30 megahertz. So you get very, very good attenuation in this area here, but it plateaus off and then increases at the end. But very good job. If I had to say, the PVC cord one probably performed the best.
Mimi's Bumblebee choke.
So proud of Bumblebee. I am very happy that I won. I think that it would be a really easy process to do, and it shows that spending a little bit more time on building your choke might actually benefit you in the long run. If you think it out, follow the process, and believe in yourself, you can do great things in ham radio.
It was a lot of fun seeing people of various different backgrounds come together and build this very simple project that any ham can do. It seems like this project gave a few of our participants some extra confidence for their own capabilities, and we hope it inspires you to do your very own builds.
Well, I hope to get my general license sometime within the next year, and I hope to be out on the airwaves and maybe even building some radios.
I have confidence to keep moving forward, try different builds, and see how my levels of expertise kind of grow from here.
It's been a boost. I feel like I still have some more to learn, but yeah, I would say it was a very positive experience.
Find more information on amateur radio at ARRL.org.